Good morning, everyone. Today is the 13th of July, and this is going to be our last lecture before our exam, which is on Monday. Let's go over it, and we'll have a lesson today. And let me go over the exam. Well, before I get to the exam stuff, guys, so somebody reminded me there are some problems I did not do from 3.3. And the plan today is go back and do some of those problems. Okay, that's the plan. So we're not going to start a new section. It's an important part that I kind of missed. I forgot. But thanks to that person for reminding us, reminding me. So before we forget, let's go over the exam. It is a cumulative exam, guys. So you want to study 2.1 through 2.4. We did 2.4 last class, last session, and we're going to kind of go back and do some problems from 3.3. And the exam is on July the 17th. Take it on that day, guys. It's not July 4th, so I won't be able to give you an extension. So please understand that, okay? July 4th was a different story. Some people were away. So I gave you guys a few more days. This time it's a one-day exam. Uh, and then the next exam is our final. I'll give you some extra days for the final. I'll explain that when the time comes, okay? So basically, next Monday, you will take the exam and I won't see you. I won't record any lecture. You won't meet with me. Then we have 3 days. We'll go over notes and we'll carry on our classes, and then we'll have our exam. All right, guys, let's get into our lesson today. So back to 3.3. So it's not a difficult section. We will solve it, but they want us to find 6 solutions. And I think your book may say find the smallest 6 positive solutions, but I will go over it. It shouldn't be a problem. All right, so let me take this problem. I'm going to do a simple one today. I'm going to start with a simple one. Actually, I don't mind taking these 4 problems and doing one, all of them. They're not consecutive, so there's a nice gap. Let's do these 4, okay? One at a time. And let me go grab my unit circle. That does come in handy. Okay. Now, if the font is too small, you kind of have to tell me. I can make it a little bigger. I do have a laptop here. My screen is not huge. I don't have 2 screens, so everything is here. All right, guys, let's work on 37. And how am I going to tell you the one I'm working on? I'm going to circle it like so. So we're working on this one. Okay, it's not difficult. Okay, a couple of things. Well, let me go back and show you a couple of things, okay? That's important, okay? You want to remember it. And we have done these things, but I'm going to remind you again. Look at the graph of y equal to sine x. And I'm going to go back and change it to like we did, negative 3 pi to positive 3 pi and step pi over 2. All right, so this was discussed a long time ago, but that's not the point. The point is you want to graph it and you want to recall that the period for sine theta is 2 pi. What does that mean? That simply means after 2 pi, the curve is repeated. Okay, the same thing is true for cosine x. After 2 pi, from here to here, that's 2 pi. This is all you need to know. Everything else is a copy of this. Okay, keep that in mind. What about secant and cosecant? Same, 2 pi. Secant from here, 0 through 2 pi. If you take this part and repeat it, you'll get the whole curve. Same thing, the period for cosecant is also 2 pi. From here to here is everything. Take a copy of it and stamp it on the right, stamp it on the left. You have the whole curve. Now, tan and cotangent have a different period. Their period is pi, and I'm going to show you right now. So pi from 0 through pi. This part is the period because this is being repeated. This is the smallest unit that's being repeated. So you have to remember that for this section. And if you forget, well, you have your computer. You go look at the computer and you have your notes. Same thing for cotangent. 0 through pi. This is the part that's being copied on the right, copied on the left. That's what we mean by period. So keep that in mind. Getting back to our main question and recalling that the period for sine theta is 2 pi. So we're going to say, okay, for sine theta and cosine theta, you have to find the answers in the whole circle, 0 through 2 pi, okay? Because we are finding more than one answer here, okay? We're looking for the 6 answers, that's more than one. So I'm going to find this for sine theta, cosine theta, secant theta, cosecant theta. I'll find the solution in the whole circle. By the whole circle, I mean this. Okay? For tangent and cotangent, you can find the period, find the answer in half a circle. Because the period is 180, that'll catch the next one. That's the argument, okay? You can find both, doesn't matter, it'll be repeated. You'll see what I mean. Now, another thing, I'm going to go here and, well, let's do it now. Integers. What are integers? Integers are these numbers, okay? 0, comma, plus minus 1, comma, plus minus 2, comma, plus minus 3, comma, dot, dot, dot. These are called integers. Now, I'm just going to write integers here. And you're going to hear this word a lot from me. Set of integers is a better term. Set of integers. Now, we'll use it in a second. Just to let you know, people use it like this. There's a symbol. It's a Z symbol. I don't know why they use Z, but they do. They write it like this, okay? Many people will write it like this. I don't have a way of writing it here nicely, so I'm handwriting it. So be familiar with it. These are integers, okay? What are integers? 0, then plus minus 1, plus minus 2, plus minus 3, plus minus 4, so on and so forth. I'm going to keep it here because we're going to use it. All right, going back. This is not that hard. Look at your unit circle. Sine is the y coordinate. I get 1 here. I get this point, and then I get, I believe, this point. These two. Okay, here it's minus half. I'm looking at the y coordinate minus half, so that's all I have to worry about. What are these two angles? I am going to say theta has to be pi over 6. I prefer radian, or in the first circle, in 0 through 2 pi, 5 pi over 6. 5 pi over 6. I'm going to fix it. Don't worry. All right, so I got two solutions. I got two solutions in 0 through 2 pi. I don't have anything in the lower half. Now, I want to find all solutions. It's called general solution. General would simply mean take this, all right, and say, add, remember the 2 pi? 2 pi is the period. P 2 pi. Now, most of the time, the 2 pi coming from the period, P put 2 here. That's the convention. And I'm going to take this. I'm going to stick my 2k pi here. K is an integer. What is an integer? 0, plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 5, so on and so forth. So this is the general solution. I'm going to write it here. That's important. And your book will ask you to do some of those. Okay? So general solution. Okay, that's good. Knowing the general solution is actually good enough. Now finding the sixth solution is easy. Let's say they want you to find the six. They want you to find 6 of the smallest solutions. I think your book is very specific. They might. So all you have to do is go back, replace this with 0. When k is 0, well, let's do it carefully. Let's do it. Okay. All right. So I'm going to take the first one. I'm going to take the first one. When k is 0, this whole mess is gone. Okay. And if you want to list the smallest one, try this one, 5 pi. I'm just replacing k with integers. Okay. Smallest possible integers. The first one, I replace k with 0 in both cases. Okay. K is 0, this mess is gone. K is 0, this mess is gone. Then I'm going to replace k with positive 1. What happens if I replace k with positive 1? It's a little bit of work, okay? I'm going to show you what I mean. This, and if k is positive 1, I just have 2 pi. And do the same with the next one. 5 pi over 6 plus 2 pi. I already got 4 of them. The next time I'm going to replace, I'll fix it, I'll bring it to the nice place now, to the right place. So I replaced k with 0, I got these two. Then I replaced k with positive 1, I got these two. I could have replaced it with negative 1, but I'm finding the smallest 6 positive solution. Then I'm going to replace k with 2. This will become 2 times 2, 4. And this will become 4 pi. I have my 6 of the smallest solution. I'm almost done, guys, but just it's a little cluttered. I'm going to take it to the next slide. And now I really have to combine these two properly, so on and so forth. So how do I do that, guys? Easy. So I have to have the same denominator. I'm going to show you the first one, then I'm going to do the rest in my head. This is going to multiply top and bottom by 6. That's going to give you 12 over 6. Now that you have the same denominators, you can just say 13 pi here. And this is incorporated. Same kind of a deal. 6, if you multiply this by 6, you're going to get 12. 12 plus 5 is 17. I'm just adding fractions. You can use it. You can do it the way I'm doing it. You can use it. You can find a graphing calculator online. There are tons of them. Just do it that way. I multiply 4 by 6 and bottom 6 by 6. Denominator is common. 24, this will be 25. Very easy to mess up, okay? And this is 24. Oh boy. Give me a second, guys. Okay. So this one, let me double check. This one is this. Okay. So the mistake is right here. 5 and right here. 5. No big deal. Caught it. So what do you do here? 12. 12 plus 5. 1, 2, 3. 12 plus 5 is 17. That's correct. The way I am doing it, I shouldn't get anything repeated. Okay, 24 plus 1 is 25. That sounds about right. All right, 24 plus 5 is 29. 29. So these are the answers I'm getting, and I got the lowest, smallest, 6 of them. Let me go back and write a 5 here because I just copy pasted and didn't fix it. So my answer, I'm going to check my answer. I have all the slides, whichever one you guys want to talk to. These are the 6 lowest answers. Now, if you wanted to use a minus, they didn't have any condition. They said, just give me 6 answers. You could have, no problem. Let me go back, check my answer, okay? And then we'll be happy to take some questions from you guys. This is 3.3. And we are working on number 37. All right, so we got it right. Now, let me do one more thing, okay? Just to guarantee that I didn't mess up. It's very even difficult to check. I'm going to bring this guy here. put it right next to this. Yep, we got it. We got all of them right. Now let's pause here a little bit, okay? So I'm going to take this guy. I'm going to bring it here. I have everything here, everything that we can talk about. I'm going to give you a little bit of time, guys, to reflect on it, okay? It is hard. I know we don't have a whole lot of people here, but it is hard. Whoever is here may ask me questions. All right, guys, let's do the next one. We're going to do this one. I don't know why this is acting a little funny, but we'll see. Okay, we got it. We're doing this one. All right, we're doing this one. All right, from the units, again, the period for cosine is 2 pi. I'm going to find the answer in the whole circle. Negative cosine is x coordinate. Negative square root of over 3 is this guy and this guy. Okay, hence the answer, the basic answer in the first unit circle, 0 through 2 pi, theta has to be, like before, 5 pi over 6, the first one, and the second one is 7 pi, pi over 6. Fine, not a problem. Now, general solution is these two numbers plus 2k pi, and you should say k is an integer. Excuse me, guys. K is an integer, 2k pi. Where's 2k pi coming from? 2 pi is the period, k is the integer. It could be 2 pi, 2 pi times 2, 2 pi times 3, 2 pi times 4, or of course minus 2 pi, minus 2 pi times 3, minus 2 pi times 4. All right, I got my general solution. That's always a good sign. Now, to find six of the smallest solutions, or to find any six solutions, I have to replace k with either 0 or plus minus 1 or plus minus 2 or plus minus 3, whatever I choose to do. So most of us tend to choose the smallest possible numbers. And I think, if I'm not mistaken, your book says six of the smallest possible solutions. Let's do those. I'm going to take this guy here, bring it here. Okay. The first one is easy. The first one, we replace it with k. We replace it with 0. And it's nice to keep them in order, right? You want to start with the real first one, and then the one that's coming up, the next one. This time, I'm going to add 2 pi, because k is 1, 2 pi. Then I'm going to do the same thing here, plus 2 pi. Good. Then I'm going to add, when k is 1, what I add is 2 pi. When k is 2, I'll be adding 4 pi. Almost done, isn't it? Now, I'm going to go to the next slide and convert them properly, and I do need room. So and I'm going to do it right here like before. That sounds about right. Now, let's combine the third one, fourth one, fifth one, and sixth one. There's going to be 6 times 2, 12. 12 plus 15 is 17. This time is 12 plus 17 is 6 times 2 is 12. 12 plus 17 is 19. 24 plus 5 is 29. I'm adding the fractions. 24 plus 6, 24 plus 7 is 31, if I'm mistaken. Now let's check the answer. And what we did was number 40. Let's bring the answer here. I think I got it right. So far, it looks like I did. But let's bring this guy here and make sure everything is in order. 31, 29, 19, 17, 5, 6, 6. Okay, that we got it right now. Take this guy and put him back here. Oops, sorry. Right. Put him back here. We have our answer. We have everything. I would like to do two more. And I think I would like to do 43 and 46. Okay. And I should be able to squeeze in 46 in this session, but I'll give you guys a couple of minutes to see if you have any questions for me. I'm drinking water. Wonderful, guys. Let's move on. Let's do the next one. All right, this guy, what's going on here? So first we have to do a little bit of math, which is not terribly difficult, just solving for cotangent theta. I can say cotangent theta, if you move things around, is 1 over square root of 2. Just move things around the way you would, as if you're solving for x. You got this. This is equivalent, okay? Cotangent theta, remember, cotangent is cosine over sine. Let's find out where can I divide cosine over sine? That looks like a good one. Square root of 3 over 2 divided by half, 2 and 2 cancel. That's cosine, that's going to give you square root of 3. So square root of 3 over 2, square root of 3 over 2, comma, half is what I'm looking for, or both are minus. Here, both are minus. That'll give me the same. So these are my two answers. All right. Now, how do I write it? My basic solution in 0 through 2 pi, theta has to be pi over 6 or 7 pi over 6. That's the basic one. Again, the period for cotangent tangent is 2 pi, pi. I really don't even need this, okay? I can put it here, it doesn't hurt. It doesn't hurt. I'll show you. So I'm gonna add, I can add 2k pi. I just have to add k pi, okay? Now, when k is 1, trust me, you're gonna get 7 pi over 6. So I won't waste our time. When this k is 1, you're going to get that one. So why do two strings and make your work more difficult? This is your general solution. And take your general solution and replace k with 0. You're going to get this. Okay, this is your general solution. Anything with k, where k is an integer, is your general solution. I do need a little bit of room. That's why I'm moving things around. So this guy, and the next one is plus pi. Plus 2 pi plus 3 pi, 0 pi, 1, 2, 3, 4. How many more do I need? I think we have to go up to 5. 4 pi and 5 pi. That should take care of it. I think I have 6 solutions. I'm going to go to a cleaner slide and try to work on the math. Let me see if I messed up. I don't think I did. All right, now I'm going to add it. So I'm going to multiply both. So this will turn out to be 7 pi over 6. And this will be 12 plus 1, 13 pi over 6. And this will be 18, 19 pi over 6. 24, 25 pi over 6. 31 pi over 6. And again, let me go back, check my answer, and I'll be happy to touch base with you guys, okay? This was 43. Okay. 43 is 31 over 6, 25, 19, 13, 7, 6. We got it. Okay. Taking this back to our main page, and we can wait for some questions. See how we do. So it's really not that difficult. It nicely builds on the previous section. Okay, guys, um, let's move on to the next session. I'll do a couple more where it's not too theta, and it's a nice place to stop. I'll come back. We're recording another session. Please come back. And if you have any questions, of course, the slide will be here. I'm jumping out, coming back. We are recording again. We're not done. Bye-bye. See you soon.